Hi everyone. Today we'll talk about weather balloon. What it is, what it does, why do we need it, and what are some of the concepts that is existing in the weather balloon. So let's talk about it. If we look at the weather balloon, it's made out of two main components. So there is this balloon, and then the other part is what we call payload, and this is a balloon, and it has gas in it, and we'll talk about it, which gas and what it does. Now why do we need gas, and why do we need weather balloon? But if you look at the whole the concept, weather balloon is a vehicle. So it is a spacecraft that goes up, that travels upwards, and it's a vehicle, so it is used to drive something. So the something is payload. So it is supposed, the weather balloon takes the payload up in the sky, right? And what is payload? So payload is it's a box, and it has stuff that weather balloon needs as it goes up in the sky, and we'll see, and soon we'll find out what all payload weather balloon needs, and why does we need to send a weather balloon, if at all. So we'll discuss, I think. But at this point, the thing to notice is there is a weather balloon comprised of two main components: the vehicle that takes stuff up there, and the stuff that needs to go up there. And we'll talk about both of these: vehicle gas that we use to run this, and then payload that the vehicle will take up. So let's talk about and dig deeper into why we use weather balloon, where we use weather balloon, and what it does. So this is our beautiful Earth, and then there is another fascinating layer here. It's called, and then there's another layer. So we'll just discuss the top two layers, or the bottom two layers. This is troposphere, and this is stratosphere. Okay. So if we I think this stratosphere go till 40 kilometer, and troposphere I get is 20 kilometer. So now what these two layer does, so troposphere is where all the weather thing happens. It's where we see rain, snow, whatever we see in a weather pattern, windy, everything is it's seen in this layer. And even all the aircrafts flying, so all the aircrafts that fly in this zone, all the helicopters that you see flying, they fly on this zone. Everything flies in this one zone. So that's a typical two layers. So now see, say this is a weather balloon. So we have a weather balloon that's it's here. It has a balloon. It does, and then because this is a payload. So weather balloon has, and let's use this half to design an ideal weather balloon, right? So let's have, so this is a weather balloon. This is a balloon. Then there is a thread. Then there is a parachute, and we'll discuss why we need parachute. And this is parachute. And then there is a payload. And in this one, there, as we said, there is a gas, and this gas could be hydrogen or helium. So we need a gas that is lighter than the air, because if the gas is lighter than the air, then the gas will push the balloon upwards. So if we need to float the balloon, we need a gas which is lighter than air. And hydrogen is the cheapest available gas that weather services use, but typically it's not available for for mass public use. So public primarily use helium to fill their balloon that will further go up. So now let's talk about weather balloon. In a typical case, so this is a weather balloon that we ship, that we just send up. In sometime it's here. Now it's here. Still going up. After a while, it's here. And it's and after a while it's further increasing in size. It goes up. And as you know, so as we discussed, there's something called payload. So payload is used to carry things that will help us understand the weather. Since it's a weather balloon, so it has all the equipments we need to test the weather or to understand the weather. So what do we need to know? So if suppose there is a very high wind, right? So we need some sensor to capture the speed of wind. So there is a sensor that measures speed of wind. We need to we need to know the temperature. We need to know the temperature here, temperature here. We need to know the temperature of the entire as the balloon is going out. So there is a temperature sensor there. There is also air density. So we have a density, we have a dense air. So we need to figure out if the balloon goes up, the air is healthy, the air is happy. So we have flights can fly easily, choppers can fly easily. People who are living here, who have houses on Earth, they drive easily. They don't expect a rainfall and all that. So it just monitor everything that helps weather balloon understand the temperature, understand the wind, the pattern, if any storm is brewing somewhere, and the direction of the wind and all that. So one of the interesting question is, say we are in Boston. So we get all the Boston weather balloon give us all the Boston temperature, wind speed and everything, right? So now imagine so what will happen for a storm that is coming from New York to Boston, and the storm is not in Boston yet. So that's why we have 800 weather locations around the world, and we use this balloon at the same time 2 times a day in a 12-hour difference. Primarily it's I think it's 0 Greenwich GMT and 12 GMT is when we send both the balloons across all the 800. And then if suppose there is, say, somewhere a lava storm happens, somewhere, say, a hurricane is brewing, in that case, if we need extra details, we may send some extra balloons to capture. And why do we send balloons? Because it's the cheapest way. It's very easy to put together, it doesn't require much, and it gives a pattern. And since we have, say, another balloon that goes, say, from here, right, and then this thing is here, and then this thing is here, it doesn't excuse me. So excuse me, it goes here. So now what happens if suppose the wind is in this direction, and this weather balloon says there is high wind, right? So now, and weather balloon also has a transmitter. It transmits the data to a weather station. This is a dish. So now it says, hey, there's a high wind at, say, 20 kilometers, which is heading to Boston, right? So now Boston can prepare. That's why we need all the 800 location around the world, monitor with the balloon and share data, so we get an understanding of the weather around the world. So in many cases, a weather balloon, say from say England, can say, hey Finland, I see a storm going towards you from England, so beware. So now Finland can act on that. So that's why this weather balloon, it's extremely important and it saves lives, because it gives us an accurate picture of the weather patterns and all that. Another important thing to note here is, if we keep going up, we see the balloon size increases. And why is that? Because of the Earth's gravity, right? So the pressure or the air density is pretty high on the bottom, and as we keep going up, the air density increases. That means the air pressure decreases. And since the balloon has certain air pressure when it was down, and certain pressure as it's keep going up, if the pressure around the balloon decreases, the particle inside the balloon says, hey, you know what, we have to adjust to suit the pressure. If the pressure is low, then the volume has to go high. So we'll see all the walls getting pushed out of the balloon from these tiny particles inside, the helium particles inside the balloon, and they keep on increasing the wall of the balloon. So if suppose the balloon goes here, the wall is pretty big. So it's going big, and it just keep pushing the walls out because the pressure is low. So the volume should go high, and volume is it's the entire soup of air that's inside the balloon. So at one point, say this balloon says, hey, you know what, I can't expand any further. You guys are inside pushing me out. I can't expand any further. And what will happen? The balloon burst. And if the balloon burst, the payload quickly start falling down very with a very high speed. That's why we need to attach a parachute. So if suppose this thing fall down, so suddenly the parachute kicks in, and parachute makes sure the box gets slowly down, and it doesn't hurt anyone, it doesn't hurt the equipments inside, right? So that's how the weather balloon is a very interesting concept. It's not using any motor, any gas, like anything that's running engine. It's just as flat as a balloon with the gas. It's very inexpensive, and people use weather balloon for various other things. So monitoring. So there's a lot of layer activity going on in which people, I think recently we saw the rave of sending cameras to the space, and recently we even sent our friend Felix Baumgartner to go to the space and do a space jump. So he went on the same weather balloon, big weather balloon, and in the payload, he sit inside the payload. As it gets up, he just jumped from so that's the highest jump any human have taken, and kudos to team Red Bull and Felix Baumgartner. They have done an amazing job. So with that, this concludes the video of weather balloons, understanding weather balloons. So again, the important part is there's a vehicle which is balloon with a gas. Then there's a parachute that helps payload get downwards if the balloon bursts at the high altitude. And then the payload, which has bunch of sensors and transmitters and all that thing that will get us all the data that we need to understand the wind and understand the weather and make sure we know the health of the weather, so we can let everyone know so they stay safe. Okay, so with that, thank you so much for watching this video. Do share and do let us know if you like and if you want us to cover anything else, and looking forward to see you till the next video. Keep inventing. Bye bye.